Hi everyone, welcome back to our channel. Today we are going to verify this Tellegens theorem for lab purpose. So actually in the lab also we are going to verify theoretically and practically this circuit. Okay, let's try to see what are the theoretical calculation and what is the verification involved in this theorem. Okay, so let's try to do our theoretical calculations. So if possible, in the next video, I can show you the practical demo of this validity of Tellegens theorem practically also. Okay. So see here, I want to find out the current in all the branches 47, 2000, 547, 2000 and 500. So that's why I am assuming this as a node Vx and this as a node Vy. Okay. So to understand this theorem well, I'm going to apply the nodal analysis. I'm assuming the current in this branch as I1, the current in this branch as I2, the current in this branch as I3. Okay. And here also this current in this branch as some I4, the current in this branch as I5, the current in the branch as I6. If I find I1, I2, I3, I4, I5, I6, then I can find out the current in all the resistive branch. Okay, so in later we have to prove that the algebraic sum of voltages and currents of the sources is equal to algebraic sum of voltages and current consumed by the elements. Then this will be very useful to us. Okay. So in before going to this, to find the value of Vx. Okay, so let's first find out the Vx and then you can find out I1, I2, I3, and then you have to find out Vy, then you can find out I4, I5, I6. Okay, so here we are going to apply nodal analysis at node Vx. If you apply the nodal analysis at node Vx, is indirectly applying Kirchhoff's current law at node Vx. Okay, here you can see here any entering currents are there? No, all are leaving currents. And I can write down entering currents is equal to 0. The leaving currents are I1 plus I2 plus I3 is equal to 0. Okay, and similarly I have to find out Iy. Why? Because I want to find out I4, I5, I6. Okay, so similarly apply nodal analysis at indirectly applying nodal analysis nothing but applying Kirchhoff's current law at node Vy. Okay, so what are the entering currents? Here also you can see here there is no entering current, all are leaving current. Therefore 0 is equal to I4 plus I5 plus I6. Okay, so these are all the leaving currents. So now let's try to write down. You can see here I1 is the current. You have to understand in further. I1 is the current across 47 ohm. I2 is the current across which ohm? 2000 ohm resistive branch, and I3 is the current across 547. So this is 547, 547, and so we have to understand I4 is the current, same current as 547, and I5 is the current across this 2000 ohm, I6 is the current across 500 ohm. So here you can see here basically this is one T network, this is another T network. Indirectly this is also cascade of two T networks. Now let us try to solve the problem. So I can write down 0 is equal to, so how to write down the current 47, this I1 current I have to write down. So this I1 current I can write down. So what is the voltage at this point? So this is nothing but flex Vx, and current is, what is the leaving terminal here you have, minus 30 divided by 47 plus, how to write down the current I2? So this current I2 I can write down it as Vx minus 0 divided by 2000 ohms. Okay, and how to write down the current which is flowing in this branch, complete branch? So plus Vx, and here this is nothing but plus or minus, or the leaving current, minus Vy. Vx minus Vy divided by 500 plus 47, which is 547. Okay, so now we need to find these values of Vx and Vy. So in order to segregate it, let's try to segregate and write down. So this is Vx by 47. This is minus 30 by 47 plus Vx by 2000 plus Vx by 547 minus Vy by 547. Okay, so separate constant and this terms. Okay, so here I can bring this constant to this side and I can write down 30 by 47 is equal to, take Vx term as an common term. So Vx of 1 by 47 plus 1 by 2000 plus 1 by 547. Okay, next take Vy term as an common term, which is nothing but Vy divided by 547. Okay, so then we will be getting these values. Okay, so now when you look out into this problem, so take, use your calculator, then you are going to get this as 0.638 is equal to Vx of 0.023 minus Vy of 0.001. Okay, so we can solve it. So similarly, I want, this is equation 1. Similarly, I need to find out equation 2, then I can get the values of Vx and Vy. Okay, so how to write down this current is 0 is equal to, so what is the current which is flowing in 547 resistor. So how to write down this I4 current, so this is the current flowing in this direction. Okay, how to write down is Vy. Okay, so this is flowing in this direction, that's why I have to write down Vy minus Vx divided by 547. How to write down the current which is flowing in this branch? You can write down it as Vy minus 0 divided by 2000. So how to write down the current which is flowing in this branch, which is nothing but I6, this is nothing but Vy, and what is the leaving terminal of the voltage? Minus 30. Okay, divided by r value is how much? 500. Okay, so here we can segregate x terms and y terms. So 0 is equal to Vy divided by 547 minus Vx divided by 547 plus Vy divided by 2000 plus Vy divided by 500 minus 30 divided by 500. Okay, so here you can bring the constant and x terms and y terms. So when you write down, this is nothing but 30 by 500 is equal to minus Vx by 547. Okay, so Vy term I'm taking as common. When you take Vy as common, which is 1 by 547 divided by 1 by 2000 plus 1 by 500. Okay, so from here we can express this as, so this is Vx minus Vx of 0.0018 plus Vy of 0.00432, that equal to 0.06. Okay, so this is what we are going to get. So when you use your calculator, then solve this equation 1 and equation 2. So therefore, you are going to get the values of Vx is equal to 29.01 volt by using your calculator. You can solve it. So and Vy value, you are going to get it as a 25.97 volts. So like this, you are going to get Vx value as well as Vy value. So now from here, we need to find out the currents in all the branches. Okay. So now let's try to find out from here. So what is the current I1 across 47 ohms already we had done. So this is Vx minus 30 divided by 47. So this is 29.01 minus 30 divided by 47. If you perform it, you are going to get it as minus 0.02106. So we need to express in milli. So in order to express why, because we have only milliamperes meter, multiply and divide with 1000. So when you multiply it, how many zeros are there? 1, 2, 3. This is nothing but minus 21.06. This 1000 will go up and you can write down this as minus 21 milliamperes. Similarly, I want the current I2, which is nothing but this current. So just refer this current I2 across 2000 ohm. Okay, so which is nothing but Vx minus 0 divided by 2000. Vx is how much? 29.01 divided by 2000. When you perform, then you are going to get it as 14.5 milliamperes of current. And similarly, the current at 547. Okay, so current I3 across 547 ohm resistance is equal to Vx minus Vy divided by 547. What is the value of Vx? 29.01 minus 25.97 divided by 547. So when you do it, then you are going to get as 5.5 milliamperes. Okay, so successfully we find the currents. Okay, so next we need to find out these three currents also. Now we require the fifth current I5 across 2000 ohm resistor. So what is this I5 current is Vy minus 0 divided by 2000. Okay, what is the value of Vy? 25.97 divided by 2000. Okay, so when you do it, so you can verify this as the algebraic sum. I1 plus I2 plus I3, if you add, it will be equal to 0. You can see here minus 21, 15.5 plus 5. So 15 plus 5 is nothing but how much? 21 approximately. So you will get the same. So I1 plus I2 plus I3 is equal to 0. So this will be validated. Okay, this will be equal to 0. That is what is the proof for that, whether the answer is correct or not. So if you do it, therefore you are going to get the current here as a 12.98 milliamperes. Similarly, I require the current I6 across 500 ohm resistor, which is nothing but, so this one 500 ohm resistor, Vy minus 30, Vy minus 30 divided by 500. So what is the value of Vy? 25. The value of Vy is 25.97 minus 30 divided by 500. When you perform it, then you are going to get it as a minus 0.00806, and you multiply with 1000 and divide with 1000. This 1000 I can write down it as milliamperes, and when you multiply it 1, 2, 3 is nothing but minus 8.06 milliamperes. So when you add I4 plus I5 plus I4 and I3 both are same. You see here, what you have to understand is I3 is equal to minus I4. So here I3 is traveling in this direction. I4 is traveling in this opposite direction. That is what the clarity you need to have. So now we successfully find the currents in all the branches. Let's try to represent the voltages and currents. Then we can solve it in a better fashion. Okay. So now use this and try to write down, represent all this in one diagram. Okay, so I am representing all the currents and voltages. So this is the battery, and this is nothing but the 47 ohm resistor. and after here you are going to have a one more resistor, and continued with a one resistor is nothing but 500, and next resistor is 47 ohm, and we are going to have one more resistor which is nothing but 2000 ohm resistor, and here we are going to have a one more resistor which is 500 ohm and excited with a voltage of 30. So 30 volts we are excited here at input side as well as at output side we are exciting with 30. So this is a 47 ohm resistor, this is a 2000 ohm resistor, this is a 500. Okay, so here I obtained the currents, I am marking the currents. Okay. So the current which is flowing in this branch, okay, already we have find the current which is flowing in this branch is how much? Minus 21.06 milliamperes. So what is the current flowing in this branch is, see here, 14.5. So 14.5 milliamperes. What is the current flowing in this branch? So 5.5 milliamperes in this direction. 5.5 milliamperes. Okay. So the current which is flowing in 2000. This 2000 is how much? 12.98 milliamperes. Okay. The current which is flowing in this branch is how much? Minus 8.06 milliamperes. Already we had find the value of Vx. Vx is how much? This is 29 volts. Okay, this is how much? Vy, which is 25.97 volts. This is zero potential, zero potential, zero potential, and zero potential. Okay, so here having all the currents in each branch. Now let's try to find the voltages also. Okay, here you see here what is the voltage drop across 47 is. So what is the current? Minus 21.06 milliamperes into 47. Okay, so when you find out, then you're going to get it as a minus 1 volt. Okay, and we need to find out voltage across 2000. What is the formula for voltage? I into R. I is how much? 14.5 milli into 2000. When you multiply it, then you are going to get this voltage as 3 volts. Okay, and voltage in this branch, voltage across 547 ohm branch is how much? 5.5 milliamperes multiplied with 547. Okay, so it is nothing but I into R formula. Then we are going to get it as 3 volts. Okay, so this not 3, this 29 volts. You can see here voltage across this also Vx is also how much? 29. This is also of same. And similarly, so this is very important for lab. Why? Because in the theoretical exam you have to prove this. Then only you'll be able to do the lab. Okay. So voltage across 2000 is equal to what is the current you got? 12.98 milliamperes into 2000 ohm. So when you do it, you are going to get it as 26 volts. You can see here, you already by node also you got the same. So the volt, and now you want to find the drop across 500. So drop across 500 ohm resistor is equal to minus 8.06 milli multiplied with 500 value. Then we are going to get it as minus 4 volts. So now successfully we find all the voltages and currents of the network. Now what you have to do is you have to do the product. So if you want to verify, you can verify here. So the voltage which is flowing in this direction, here we have got as how much? Minus 1 volt. So here already we have been obtained as how much? 29 volts. Okay. If you apply the KVL, okay. So what is the voltage at this point? 30 volts. Okay, current is already coming in this direction, therefore this is plus 30, and what is the leaving polarity here we have is plus into what is that voltage minus 1 volt, and this is how much, leaving is how much, minus 29 is equal to 0. So 30 is equal to 30 volts. Okay. So your KVL is also verified. Similarly, in 30 volts, how much is the drop here? 1 volt. Therefore, 29. So this 29 is once again splitting as how much? What is the drop created in this branch is only 3 volts. Okay. So 29 plus 3 you will be getting as 29. So when you apply the KVL. Okay. So what is the voltage at this point? 29. So 29 volts, and leaving terminal is how much? Minus 3. And here this is a 25 and this is minus 25.9. So if you do average, 29 is equal to 29. Your KVL is verified. So all the voltages are balanced. Now we want to find out the total power. Okay. So I'm going to find out the power across 47. Okay, so now the power delivered at 47 ohm resistor is equal to what is the current which is flowing in this branch is minus 21.06 milliampere into what is the voltage minus 1 volt. So when you do it, you can calculate the power. So now I'm calculating the power across 2000 ohm resistor. Okay, so what is the current? 14.5 milliamperes into what is the voltage we are having, 29 volts. Okay, and similarly power across 547 is equal to, so what is the current which is flowing in that branch is 5.5 milliamperes into what is the voltage which developed here is 3 volts. Okay, so similarly we need to find out the power across the 2000 and 500 also. Okay, so power across 2000 ohm resistor is equal to, so this power, okay, so this current is how much, 12.98 milliamperes into what is the voltage at this point, 25.97 volts. Okay, so similarly power across 500 ohm resistor is equal to minus 8.06 milli into what is the voltage you had got, minus 4 volts. So when you do it, then here you are going to get 21 milliwatts, and this is 420 milliwatts, and this is 16.5 milliwatts, and this is 337.48 milliwatts, and this is 32 milliwatts. If you add all these things, then you are going to get 826 milliwatts. Similarly, so this is the sum of power. Okay, so this is the sum of voltages and currents delivered by the load. Okay, so similarly, we want to calculate power consumed by the sources. What is the current power due to source? So what is the total voltage? 30 volts. And what is the total current? So total current is how much? 21. Okay. So 21.06 milliamperes. So this is the current which is flowing in this branch. And what is the power by this source? Power due to 30 volts source is equal to total voltage is how much? 30, and into current of 8.06 milliamperes. Okay, this is also milliamperes. When you multiply, this is 630 milliwatts, and this is 258 milliwatts. So approximately you are also going to get 826 milliwatts. So what is the concept of this problem is, you can see here. So this is the total voltage and currents delivered by the source, power delivered by the source. This is nothing but 826. So I can prove that the total power by the delivered by the source is equal to the total power supplied by the load. But the total power supplied by the source 826 milliwatts, but the total power supplied by the load, which is nothing also 826. Or you can write down. So the power supplied by the source and power supplied by the load is equal to 0. If you feel the content is clear, just go through the problem again and again. Okay, so this is very important in the lab point of view while you are solving. Okay, so just very simple, we are finding the all the currents in all the branches by using nodal analysis, and just you are multiplying voltage and currents, then you are going to get the power at each level. Okay, and we are balancing it. Okay, so total power supplied by the load is how much the power is supplied by the sources is 826. How much is the power consumed by the loads or resistors is 826 milliwatt. Therefore, it is balanced. Therefore, power supplied is equal to power consumed by the loads. Hope if my explanation is correct, I've done it for to make the things very clear for you in the lab point of view. Hope you are able to understand. If you feel my explanation is good, please like the video and share to your friends, those who are studying the same subject. If you have any doubts, let me know in the comment section. If you're watching the channel for the first time, subscribe to my channel for more updates on circuits and electric vehicles by the channel name KV Tulsiram. Kindly support this sort of free channel for the development of students and faculty. Thank you for watching the video carefully. Just go through the video slowly, one by one, and each point one by one, then you can understand better. Thank you for listening patiently.